Good morning, guys. I hope you enjoyed your little vacation, right? And I hope you have even learned something, right? So, we'll start with the portion from where we left off. There was a small portion pending, which I will take in the last section, which is regarding the pulley system itself, right? So, the first section which we are going to start is new today. It's a new section, right? So, we'll start with a new topic, Newton's third law. No, I am telling it or teaching it explicitly because actually I have talked about it in almost all the equations or almost all the problems we have dealt with. We have already talked about Newton's third law. That is, every action has equal and opposite reaction. It's not a big deal, but next time you shouldn't tell that oh my god, teacher didn't teach the Newton's third law. So I'm just telling you what is Newton's third law. Every action has an equal and opposite reactions. Remember, this is the mass of block. If it is there, it will be this mass of block will be exerting a force on the earth's surface, and the earth's surface will be providing a reaction, normal reaction. This N and mg are equal and opposite forces, or I can say are action reaction pair, right? So every action, right, every action has an equal and opposite reaction. Clear? Right. So N and mg. Here mg is the action, N is the reaction which is given by the surface. Right? It's not a big deal, right? Now suppose you're given a question like this, right? There is a rope, straight rope, right, on which a monkey is trying to go up. So let's say this is a monkey. I wish to draw a monkey. Let's say this is the tail, right? This monkey wants to go up, right? So he will be exerting a force downwards, mg, right? Yeah. Now let's say he is going up with an acceleration, let's say 2 meter per second square, right? Let's say the mass of the monkey is 20 kilogram. Mass is 20 kilogram, right? And g, of course, we are going to take it as 10, right? Now the question is, monkey is pulling the string downwards, right? And the string will be pulling up, right? We know what is the tension. I'm just taking this as the monkey, and this is downward force exerted by the monkey, which is mg. Then on the string, a tension will be there, right? Clear? Right. Then if you are asked what would be the tension in the string, how would you find? You'll find this is acceleration, right, in the upward direction, and this acceleration is 2 meter per second square. So in the acceleration direction there is tension, so you would write T minus mg is equal to ma, right? That is equal to T is equal to m into g plus a, right? Just like the lift going up, right? That is equal to mass is 20, g is 10, acceleration is 2, so you will find it as 240 Newton. This is how we did the problems, right? Very simple. Now the same monkey problem. Now this is something which we have learned, right? And this was also based on Newton's third law. All the equation, all the bases we have learned till now had the application of Newton's third law, right? Right. Now let's deal with a problem which is repeatedly asked in your examination point of view, both NEET as well as even in your textbook. There is a question like this, right? Not the exact numbers. Okay, let's say the monkey is of 80 kilogram, right? G is 10 meter per second square, right? And the monkey wants to go up, right? And obviously this is, let's say this is the acceleration, right? So tension will be generated, obviously, just like the previous case, the mg will be there, right? So what is the maximum acceleration the monkey can have so that he can safely climb up, right? Question is, what is the maximum possible acceleration by which the monkey can go up so that the rope will not break, right? That is the type of question. Maximum acceleration so that the rope doesn't break, right? So that means there is a maximum possible tension, right? That is known as break tension, or this, let's say the tension is given as 1000 Newton. That is the maximum possible tension that this wire or this rope can tolerate is 1000 Newton. If the force which is exerted, or the tension which is exerted on the string is more than 1000, it will break. That is the meaning of it, right? So we are going to say what what will be the maximum acceleration, in the sense, suppose the let's say the monkey, right? Monkey goes up with the maximum acceleration. The maximum possible tension it can generate is 1000. That is the meaning, right? The maximum acceleration by which he can go up should be equivalent to an exerting a force of 1000 Newton, not more than that. That is the meaning of it. Clear? Now let's move on, right? Let's remove these and all things, right? Now, how would you do this question? Same like the previous one. You will write T minus mg is equal to ma. Right, what is the maximum tension? That is breaking tension of the or breaking force of the string. It is 1000 Newton. Minus mg, that is 80 into 10, that is 800. And ma, 80 into a, that is our maximum tension. Right, so you will get 200 is equal to 80 a max. So you can cut it out, 20, then there is 2, then there is 5, right? So acceleration is 5 by 2, or it is 2.5 meter per second square. So if the monkey goes up, right, with an acceleration 2.5 meter square, then just braking condition is released. That is, it will not break, that is, but the maximum tension has occurred, right? If he moves with an acceleration more than 2.5, let's say with 3 meter per second square, it is sure that the string will break. Clear? Right, this is the type of question. I think this type of question is there in your SME one. Let me see. I think it is in your classworks, sorry, in our classwork section. I'll tell you the number. It is 29, right? Braking strength is given, right? That is, what is the minimum acceleration with which a monkey can slide down, right? A rope whose braking strength is 3/5 of its own weight, right? Same theory, use it and try to find it. In just the difference is, in place of accelerated up, or the motion is up, the monkey is going down, and the exact value of tension is not given. Tension is given 3/5 of mg. Clear? Do it. Okay. Now the next section. So this is a surface. Let's say we are having a pulley like this, right? Let's say one end of the string is connected to a lift like this, right? And the other one is the hand of a person. He's holding it, right? Clear? Let's say the mass of the lift is 30 kilogram and mass of the person is 60 kilogram, which is very odd. Yeah, chalega. It's okay. See, don't look at the numericals. I don't make any sensible numerical sections, means numbers. Understand the question. Okay, right. Now you are asked, what is find the force which is exerted on the lift by the man. That is, what is the weight of the man, right? Or what is the apparent weight of the man, right? His obviously is the person's weight is 60 kilogram. Remember, we had dealt with the lift moving up and down. So apparent weight, you are asked what is N, right? What will be the feeling, or what will be the lift if it is there is a measuring gauge and he is standing over the measuring gauge, right? And he is doing this one, right? If this process is happening, so what will be the reading in the weighing gauge? That is a question. Clear? Simple. Now how would you consider this one? So each, I told you, whenever a free body diagram has to be drawn, you have to separately draw, right? First we will draw for the free body diagram of what? Of man. Let's draw the free body diagram of the man. Oh, we start that. See, he is pulling. Let's say he is pulling the string like this, right? So he is pulling the string means that there will be a tension here, right? And here also there will be a tension like this. Sorry, away from the body now. Sorry. So tension equivalent same string, right? So when he is pulling, right? Is trying to actually pull the lift along with him, right? I'm just telling you, he's trying to pull like this. That means he's trying to pull the lift actually, right? Clear? Right, that much common sense is there, right? So let's draw the free body diagram of the person. So let's draw him like this, right? So he is exerting 60 g downwards, his weight, right? And the earth provides a normal reaction to him, right? And in his hand there is a rope, there is a tension outwards. There is only forces which is there which when you consider the man, right? Clear? So here I can write T plus N, right, is equal to 60g, right? Simple. Now let's draw the free body diagram of the lift, right? Just the lift. Let's make that a smaller one. See, there is a tension here, so draw the tension. Now this person is exerting a weight, right? Clear? Right, he's exerting a weight means if the body, if I am telling you about the mass of the lift, there will be a 30 g downwards, right? And similarly the man is, see, when he is pulling, right, when he is pulling the string, then the man feels that the lift is pushing him up. Remember what I am telling you. See, when he is pulling the string downwards, he will feel at the foot of himself, right? At his foot he will be feeling a push upward in direction. What is that push done by? Who's the one was pushing the person? That is the lift. That means the lift is doing an action. So a person will give him a reaction, that is N. Clear? Right? Now this is a very good question. Concept should be very clear. So here I can write which equation. Here there is a one equation for the man, and the case of the lift I can write T is equal to N plus 30g, right? Clear? Right? So you have two equations. I can even make this as T minus N is equal to 30g. So you can have two equations, T plus N and T minus N. Just add them. You will get 2T is equal to 90g, or T is equal to 45g, right? So I can even, if you put G as 10, tension will be 450 Newton. That is the tension on the string where the person is pulling will have a 450 Newton. Now that is not the question. Your question is, what is the apparent weight, right? That is, I can write N is equal to T minus 30g, right? Or T minus 300, that is 450 minus 300, that is 150 Newton is what the weighing gauge will be. What is the actual weight of the person? It is 60g or 600, right? Clear? So his value is less. What I say it is less. You will see that just initially I told you, right? 60 g versus weight. What did we? 60 what did we? It would have been 600 Newton. That is the force which he is exerting on the left. But now, what will be the reading on the left? It will be only 150 Newton, right? So that means the lift will be feeling, right, only this much, or the apparent weight of the person has reduced. Clear? Going to for an entirely new topic, guys, which is spring, right? Spring, I hope you know, right? So see, it is very important. In the following mini chapters we have to learn about spring section, right? So suppose this is a spring, right? So in case of spring, suppose I apply a force in this direction, that is I'm pushing or pulling this spring. So its length increases. Let's say it is extended, or let's say it is expanded by a distance of delta x, right? Yeah. So you are applying a force in this direction then, and just like our Newton's third law, the spring has its own force developed, which is known as spring force, in the opposite direction of the applied force. Clear? Let us see. You are pulling the spring, right? So the spring itself will be having an inbuilt reaction which is against to the applied force, because spring always tries to come into its equilibrium position, right? So this FSP, which is spring force, is equal to minus K into delta X, where K is the spring constant. K is spring constant. Clear? Which is different for different springs, right? And FSP for a spring, right, or a string is actually only depending upon what? The displacement, right? This K is constant, so I can say when the displacement or the expansion or according to the contraction, FSP changes. I hope you remember tension is a characteristic of that string, right, of a string, and that is always constant for that string, right, irrespective of if you are twisting it whatsoever, there is a maximum tension which can be tolerated by the what? String. Whereas in the spring case, it is always depending upon how much it is contracted, how much it is expanded, right? So it is a variable type of force. Clear? Right. So we'll do some examples to make it thorough, guys. So this is a spring connected to a block, let's say like this, and I'm exerting a force here, right? So a spring will be exerting a FSP in this direction. Let's say the contraction is by the displacement x. So again, you can write FSP is equal to minus K delta x, right? This law is actually called Hooke's law, right? Hooke's law, right? Now if you are in your problems, you can even replace, while you are doing the problems, you can even replace the spring with string, and it is better to do that. See, because see, if you are having a string, right, in each point the tension will be same. Remember, we had drew like this. If this is the tension, so this is also tension, right? So for a string, the tension is common throughout. Similarly, for a spring, at a particular condition, FSP is always constant, right? Clear? Just the differences in the case of spring, it is very difficult to bring the value to 0 when compared to tension. Tension of a string can be made 0 in a fraction of seconds. You just have to cut it. Clear? Right? Right. So while doing problems, you can even replace the spring with a string. I'm just telling you in order to make you guys have facing any difficulties while doing problems, you can just replace it. I will take it in detail later on, right? So this is our spring, right? I exert two forces. Let's say this is F1 and this is F2, so that here the displacement is x2, here is the displacement is x1, and you are asked what was the spring force, right? If there is F1 in this direction, so there will be a FSP in this direction. If this is an F2, then there will be an spring force in this direction. That's what we told just now. So you would write FSP1 is equal to minus kx1, displacement or expansion here is equal to here minus k into x2, expansion here, right? This is what you make. I just told you that spring force is equal to minus k into displacement, or length increasing or length decreasing, right? Or change in length, I can say, right? I just told you delta x, that is change in length. But you cannot write like this, because spring force, that is FSP is equal to, we just wrote, is minus k change in length. What is the actual change in length is here? It is increased by x1 and x2, right? So I can actually write it, or I am supposed to write it as minus k x1 plus x2, not like this. You cannot split it like this and write, right? Obviously you will say I can just add FSP1 and plus FSP2. That is not the that is not the idea what I want to bring about. That is, whatever length change you are doing, that is taken in an addition, but obviously you have to consider the direction. All right, I'll tell you an example. Right, suppose there is a block like this B, and there is a block like this in A, right, and there is a spring in between, right? Let's say the spring constant is 100 Newton per meter, force per unit length is a unit of K, right? So you are asked what is the spring force in two conditions, right? Because we are going to displace both the block by 1 meter each, right? Both of them will be displaced by 1 meter, but first is when they are displaced in same direction, and second condition obviously in the opposite direction, right? So I'll tell you how to do. So we'll draw the diagram. So in same direction displaced in by 1 meter means how does that, or what does it mean? I'm not writing K. That is same direction. I can displace in this direction, then B also will be displaced in this direction. So 1 meter and 1 meter. So you're asked what? You're asked spring force, that is minus K into change in length. Tell me what is the change in length in this condition. See, you are pulling here, right? So you are pulling here, that means you are here, let's say you are trying to extend by 1 meter, but in this end you are trying to contract the same spring by 1 meter. So the net displacement or next elongation is 0. I can say FSP is 0. Here I am pulling, here I am pushing, right? So in the case of spring there is no elongation, whereas if this condition I am changing, this is B and there is a spring, there is an A, right? And opposite direction means either this one, or better to learn, both are in opposite direction pulled, right? So by 10, oh no sorry 1 no? 1 and 1 meter extension, so there is a total extension of how much? Let's say 2 meter. So FSP will be minus K. Net elongation is 2 meter, right? So it is 2K. So how much is the K written in the question? It is 100 now. So FSP will be minus 200 Newton. Clear? Right? Happy? Clear? Right. Now we'll do a lot of questions regarding the same itself. We have to make this one very, very thorough. Right? Let's say now this is a spring, right? You are having a block M. Let's say we applied some force, right? So due to which it extended, and after extension now this block along with the spring is obviously it has got equilibrium now, right? So let's say the extension which is done is about delta x, right? So when since the pulling is there, right, and this pulling is done by the weight, right? Clear? By putting the M, it's just elongated by a distance delta x. So if this choose the weight in this direction, so FSP will be in this direction. Clear? Right? That is after delta x extension, again initially, see, let's say like initially this spring was like this, I connected an M and it fell, if that is the way you want to understand, right? So after this extension is done, now it is depending upon the weight it has extended. Now further, if until and unless an external force act on it, nothing is going to happen. So you would tell me, oh then once the weight is put, obviously it is going to oscillate. Yes, obviously it is going to oscillate now, but in this chapter we are not going to consider oscillation until and until last few chapters comes up, there we will be considering oscillations. Clear? Right. In this chapter we are not going to consider that there is oscillation in this case, right? Now that means from the figure I can say at equilibrium FSP is equal to what? Mg from the figure, right? What is the equation for FSP? That is minus K. How much is the elongation? That is delta x is equal to mg, or I can write delta x is equal to mg by K. Obviously there is a minus because it shows that the extension is in downward direction, right? Now this, if your guys are feeling it is very difficult, you can just replace the spring with the string like this, right? And just write this is the tension outward. You can write T is equal to mg, right? And in place of T just write the K delta x or minus K delta x, and mg you get the same expression for delta x, right? That's why I told you, you can just, while drawing the figure, if you're finding it difficult to write FSP exclusively, you can just write it as tension and just replace it. Clear? Right? Now similarly, right, see guys, it is very difficult to find this type of explanations in any of your books. They will just give you an equation to by heart, and the proper explanation will be very difficult to understand also from the books. That's why I'm taking it. I meant this is a spring, huh? Doesn't look like a spring. This is a spring. Let's say K is the spring constant here. Right, this is a pulley system. We have combined pulley system and spring. Right, and the question is, what is the elongation of the spring? Right, so obviously you will be finding it difficult first time. So let's say we are going to replace this with a string. That is M. There is a pulley, then there is 2M. This is something you have learned, right? So this is mg, this is 2mg. There is tension upwards, there is tension upwards, right? And what is the acceleration equation? I told you a short form, net force. What is the net force here? Right, 2mg is there, right? Clear? And there is an mg, right? Both of them are in opposing action. That is 2mg minus mg is what? Mg divided by net mass is 2m plus m, that is 3m. Or I can just cancel, acceleration is g by 3, right? Short form, right? Or you guys can do this twisted way also. That is, you just write the equation for the mass m. T is equal to mg, right? But sorry, not T is equal to mg. We didn't consider acceleration, huh? So let's say this will be the downward acceleration here and the upward acceleration here. So T minus mg will be equal to ma in the first section, right? For the first mass, in 2m there will be 2mg minus T is equal to 2ma, right? Clear? Then you just add these two guys, so it becomes mg is equal to 3ma. M cancels, or you can write A is equal to G by 3. You got the same answer as well. This is quick step. This takes little bit time more, right? Now you can just include this AS value here, and you can find the tension's value. That is, tension will be equal to ma plus mg now. So T is equal to m. What is A? That is G by 3 plus mg. You will get 4 mg by 3. Now that is tension, but that is not there. Huh? It's not string here. In above m, we replaced a spring with a string, right? And in place of FSP, I wrote it as T. So now I'm just going to write, in place of T, I'm going to write FSP is equal to 4mg by 3. And FSP's equation, remember, it is minus K delta X is equal to 4mg by 3, right? That is, delta X is equal to 4mg by 3K. That is a minus. Right, that is, the displacement is in downward direction, or displacement now you can say extension is in downward direction. Happy, right? Okay, now again there is a spring, there is a pulley. Now this is 2. The figure looks so odd. Right, this is 2. I'm not writing it 2 kilogram explicitly, right? This is 2 and this is 4, right? Right, and always the spring is always considered weightless. Okay, again you are asked what is the displacement. So what should we do? Replace the spring with the string, right? This is 2, this is 4, right? So obviously this will be the acceleration direction, and this will be accelerated in upward direction, right? So the tension T here, this tension will be here, tension like this, right? So since this 2T are there, the tension will be this direction, 2T. Simple, huh? Right? Now let's say what will be the acceleration? Net force 4g downwards, 2g downwards. So net is 4g minus 2g, that is 2g divided by net mass is 4 plus 2, 6, or I can write it as just g by 3. Acceleration is g by 3, right? Now let's take any one block. Let's say 4g. In 4g or 4, from here I can write 4g, below minus T, because A's direction is mass at a 4G. This 4G minus T is equal to 4MA, right? Now, clear? You just have to find the value of T, right? So 4G of T is equal to 4G minus 4mg by 3, right? So it becomes 12. 12 minus 4 is 8, right? So you will get T is equal to 8g by 3. You know? Right? Why did I write 4m? Sorry. This is not 4m now. It is 4 kilogram into its acceleration, right? Similarly here, right? So you will get 8g by 3 as a tension. Now, you are again, what has been replaced here? This spring has been replaced by this string, that is in place of 2t, right? That is 2t is equal to FSP. Huh? So I have to find 2t. What is 2t? 2 into 8g by 3, that is 16g by 3 is FSP, right? That is, in place of FSP I can write minus k delta x, or delta x is equal to minus 16j by 3k, right? This is the displacement of that spring. Simple, right? Now let's move on. We'll do a lot of questions. Maximum possible questions we'll do, right? So this is spring, right? Let's say this is mass m, and there is a double mass, let's say 2m, right? That is, now the question is quite different, guys. That is, if at equilibrium, if we cut the string, this one, right, at equilibrium condition, that is initially, let's say the string was like this, then we connected m, then 2m, the maximum extension is possible, then we are going to cut, right? So after the equilibrium is reached, we are going to cut this string, right? So you are asked the acceleration of the blocks just after the cutting the string. We are not asked after a few times, just after cutting, just cut it. And at that moment, what will be the acceleration of the blocks? That's a question, right? So we have to deal with this in a proper way, right? So first we have to draw this diagram in the equilibrium state. That means equilibrium state means now in here, in place of this one, this spring would have extended a lot, right? And then there will be a block like this, and then there will be another block. Hannah, let's bring this one. So I will draw like this. So this is 2m, this is m. So here I will write 2mg, right? And there will be a tension here away from this m and 2m, right? Now this m will be exerting a force mg, or weight mg, clear? And here, what will be the in spring? The pulling is done by the force is downwards, the total force is downwards. So FSP will be in this direction, right? Clear? Right. So what and all can be written about FSP? See, here, let's say T. Just look at 2m. What will be the value of T? T will be 2mg. See? Because nothing is supporting. So T is equivalent to 2mg here, right? And then, so below to m, like this, below to m, there is T now. This T is equal to 2mg because of 2m mass, right? So, and there is its own weight mg, right? So above FSP, then what will be its value? Equilibrium conditions, right? Equilibrium conditions by equivalent forces in either direction. So FSP will be equal to what? 3mg. 3mg. Clear? Just add. Clear? Right? We can, if you want, I can reduce the spacing, right? Spring conditions, right? If you want, we can draw it again here, m here, right? M, and there is a 2m here, right? So 2m is exerting a weight downward, that is 2mg. Clear? Now there is tension upward from 2m, that is equal to what? It should be equal to 2mg, because then equilibrium condition is existing. So if this T is 2 mg, then the tension experienced by mass m is also 2 mg, because same string, same tension. So in case of m, we are going back to this diagram. In this case, see, m will have tension downwards 2 mg, mg downwards, then FSP's value should be just due to its equilibrium condition should be equal to mg plus 2 mg, that is 3 mg. Right, clear? Now let's remove this and all. Right, in here. Right, so what happens when this string is cut? This string is cut, the tension goes off. There is no string, right? There is no thing to pull the string, so the tension suddenly, just due to cutting, it becomes 0. But tell me, the string is cut, but there is still mass m now, right? So just the moment before, or just the moment just you have cut the string, the spring will not know what has happened, right? It takes few time for it to realize that it need not extend further. It can compress back to its initial position. So just the moment you have cut the string, we can just surely say that FSP is not equal to 0. Right? Yeah. It is FSP is not supposed to be 0 because it is sudden. Right? So sudden means it doesn't know that the string has been cut. Right? That is, this string has been cut, he doesn't know. So I can say FSP during just the cutting moment is equal to 3 mg. Right? Clear? Now we have to do the question now. We are having the mass m, FSP upward in 3 mg. Then it has what? Mg downward, and that had tension, but that tension is now 0 because there is nothing to hold it from the below section. So that means what is the net to sub, and obviously string or right. So now see, once this and all are the common sense, guys. If this block that is 2 mg is been, of course the string is cut, means 2 mg falls off, right? So what will happen to m? It moves up, right? So its acceleration will be in upward direction. That is, I can write 3 mg minus mg is equal to ma, right? Clear? That is, I can write 2g is equal to a, or a's value, or the acceleration of the block, first block m, is how much? 2g, or 20 meter per second square. Clear? Now we'll go with the 2m mass. 2m mass, obviously it is having a weight downwards, 2 mg. Happy? Now only thing which was holding it was the string, and that tension goes off, right? And it is going to freely fall, right? So with say that is acceleration is m. So how would you write? Sorry, 2 mg is equal to 2ma. 2m cancels. I can write a is equal to g. That is, this mass 2m falls with an acceleration of g. Due to gravity it falls, man. Clear? Right? Yeah. Now similarly, we have another condition. Let's say like this. Here is having a mass m. There is another mass, let's say 2m, and there is another mass, let's say, oh, I cannot include this one. Why it is coming like this? Okay. Right, another mass, let's say like this, m. Let's name this a, this is b, and this is c. Right, this consider, okay. So you are again asked, if the string is just cut, what will be the acceleration of m, what will be the acceleration of 2m, and what will be the acceleration of this ABC. Let's take it as like that, right? So previous cases we are going to extend it. Okay, I hope you understand the extended version. So the extension has occurred. Okay, that much I'm not going to show because we require the space for drawing, right? So there was an m here, let's say this is m, right? So there is another block, what, 2m, right? Clear? And there was another block, let's say, what was it? M. Right. Clear? Great. And this M was having obviously what, and now I'm going to draw the free body diagram in the equilibrium conditions. Right. Oh, sorry, there is a spring here, no? So I'm sorry. There is a spring here. Of course, that is expanded. I'm not explicitly shown. I hope you understood. So this is a weight mg downwards. Now what will be the force FSP here? FSP will be equal to mg. Then only the equilibrium is achieved, right? Clear? Right. Now if this is FSP, then here in this end of the spring also FSP is what? Mg itself, right? In spring, throughout the spring force will be constant. Now what will be 2m experiencing a weight downwards, which is 2 mg downwards? Clear? Now what will be the tension then? Tension's value here, it should be equal to 2 mg. Then see, if I explicitly draw 2m outside, there is an FSP which is value is mg here and its own weight 2 mg here, and you have drawn a tension in the outward direction. So what would be the value of tension? It should be equal to 3 mg. So this is 3 mg. Clear? If this tension is 3 mg, so this tension away from m is also 3 mg, right? Now this mass is experiencing a weight downwards, how much? Mg. So totally, if I draw m in outward direction or separately, there is a tension which value is 3 mg downwards and its own weight mg. So what will be the upward force, which is actually FSP of the first spring, which is equal to 4 mg. You know? So I can write here FSP is equal to 4 mg. Clear? See, I know I have taken it fast. Just pause the video and see if you have understood it. Clear? Now what happened is you are breaking, right? You are breaking this one, right? So what happens? The spring is moved, or sorry, the string is removed. Obviously the tension from 3 mg it falls to 0 suddenly, right? So again, so what and all were the value? Let's say this is C, this is B, and this is A. We are going to consider C, B, and A separately, right? After the string is cut. So let's say this is M, that is C, right? What was M experiencing? It was experiencing a weight downwards, right? Mg, that is good. There was tension. Now the tension goes off because the string is cut, right? Now upward there is a force FSP. I told you the spring will not know what has been happened regarding the tension of the string, so it remains 4 mg itself, right? Now when the spring, or this, sorry, not spring, the string is cut, right? So below 2 blocks down falls downward, or I can say accelerated downwards. What will be the acceleration here of the M block C mass? It will be accelerated upwards. Now write the force equation. You can find the answer by yourself, but first we will draw all the diagrams. That is better. So let's talk about mass B, right? So again the mass is 2m, right? Again this tension goes off, there is nothing, and the tension, if I take this, tension is equal to 0, and below its weight 2 mg is there, and below springs FSP, which is equal to mg, is there, right? And it is accelerated, this mass is accelerated downward. Happy? Now similarly, what can I say about A? Right, A's mass is m, its weight mg, right? Upward FSP is what? Mg itself. So will it be accelerated? No, acceleration will be 0. So I can now itself I can write acceleration of A is 0. We got one of the mass acceleration. Clear? Now from these two diagrams, find the value of acceleration of A and acceleration of B. Now what will be the acceleration of A? Now we have found the acceleration of A. Let's say talk about acceleration of B. So I can write, see, in the A direction there are two forces, which is 2 mg and mg. That is, I can write it as 3 mg is equal to 2m, mass into acceleration. Cancel m, or I can write 3 by 2 g is the acceleration of mass B. Clear? Right? Now similarly, let's talk about C. right? In the case of C, what and all you can find, there is an acceleration upward now, so that is MAC is equal to, in the same direction you are having FSP, right? So I can write FSP minus mg, you know, FSP minus mg is equal to m into a. Let's say that is acceleration of C. So acceleration of C is, what is FSP? That is 4 mg, we have written there, minus mg divided by m, right? So you will get AC is equal to 3g. That is the acceleration of C. Clear? Right? I hope this much is clear. Right.